Welcome back to Summarize Science, where we look at the cutting edge of robotics. Today, we are exploring a new foundation model called Psi-Zero, designed to help humanoid robots master complex daily tasks. Most robots today are good at either walking or using their hands, but combining these movements is a massive challenge known as Loco-Manipulation. The researchers behind this paper have introduced an open-source system that allows robots to navigate environments while simultaneously performing dexterous tasks like wiping tables or pushing carts. To bridge the gap between human and robot movement, this system uses a clever staged training paradigm. First, the model watches over 800 hours of human videos filmed from a person's own perspective while they work. This allows the robot's brain to understand the basic logic and visual goals of human activities. Then, the model is refined using just 30 hours of actual robot data to learn the specific mechanics of its own mechanical joints. This two-step process is much more efficient than previous methods that tried to teach robots everything all at once. Looking at the architecture, the model uses a triple system approach to manage everything from high-level planning to low-level motor control. System 2 acts as the vision language backbone, processing what the robot sees and what the task instruction is. System 1 is the action expert, which predicts the next sequence of movements the robot needs to make. Finally, System 0 handles the physical balance and leg movements to keep the robot upright. One major breakthrough here is how they handle action chunking to ensure the robot doesn't move in a jittery or robotic way. By predicting chunks of future actions at once, the robot can move smoothly even if there is a slight delay in its computer processing. The researchers tested this on a real-world platform called the Unitree G1, which features 29 degrees of freedom for its body and dexterous hands. They set up a series of complex tasks in a pantry environment, such as taking a cup from a coffee machine and placing it in a sink. Other tasks included pushing a fridge door shut and even wiping down a table with a rag. When compared to other state-of-the-art models, Psi-Zero outperformed them by over 40% in overall success rates. It was able to accomplish these feats using significantly less data than its competitors, proving that the quality of data matters more than the quantity. This research identifies a critical data recipe that prioritizes high-quality human manipulation trajectories, followed by specific robot demonstrations. The system also includes a specialized teleoperation setup, where a human wears a VR headset and motion trackers to teach the robot new skills. To recap, Psi-Zero is a major step forward because it decouples the learning of what to do from how to move. By learning general logic from humans and specific control from robot data, it achieves superior performance with much less training time. The researchers have released the entire ecosystem, including the training pipeline and the model weights, to the public. In the future, this could lead to more affordable and capable robots assisting us in our homes and workplaces. Instead of needing thousands of hours of specialized training for every task, robots might just need to watch us for a little while to get the gist. This move toward universal humanoid control marks an exciting era for artificial intelligence in the physical world. Thank you for watching Summarize Science, and stay tuned for more breakthroughs in the world of technology.